go and find my stuff. My computer, I'm still not used to it. I had everything lined up and now it's disappeared again. So just bear with me a second. Well, this is the references. I'll share that with you. So firstly, I've made a list of the references we've talked about so far. Can you see that?
Yeah.
Yep.
So these are the things that you need to be aware of. I mean, these are some of the things you need to be aware of, but these are the more important ones. NCC, AS 1668, ERA design guides, ERA technical manual, design checklists and flowcharts. We haven't really gone through that, but we can talk about that another time. But this information is all in your files, so I can just show you where it is, and this is quite helpful. The Camel User's Guide and software, Fantech fan selection software, AC equipment selection software, fan static calculation sheet, equipment schedule forms, duct size calculator, Revit, Bluebeam, levels of detail. So you've probably touched on all of these things so far. Now I'll just get this other one. It's the same one. That's what I'm looking for. So now, the process so far, can you see that?
Yep.
Right, so this is just a summary of the important steps that we've talked about, and this hopefully puts it into a bit more perspective for you because we've just sort of gone through each section, but just to summarise it, and I've just put a note there that something that I always remember is that all work we do is a process. So it's step by step working through, following a system, and that way it's your most efficient way to get to the answer. So we've talked about HVAC, heating, ventilation and air conditioning. That's really a North America term, but we've adopted it in Australia now. Really, air conditioning in Australia means cooling and heating, but HVAC is commonly accepted here now. We've talked about the standards and codes, in particular the NCC and AS 1668. I've mentioned the ERA guides. We haven't gone into those, but I've talked about the technical manual. They're really important to understand what's available in those references because there's a huge amount of information, which is very helpful. We've talked about specifications, briefs, agreements, setting up, giving you the documents you need to start a project. FER, Fire Engineering Report, always important to look at that. If there is one for the project, you must have a look at that and see what it's saying. Energy reports, acoustic reports, and other reports. They all form part of the documentation that we have to comply with in a project. Just let me do something here. Okay. Design and construction program. Timing is always critical. I'm sure you've become aware of that now, that things are always done to a certain time frame. Sometimes we have conflicting time frames and we just have to sort out the priorities. But it's important to be aware of the program for the project so that you can keep up with that. We don't want to get left behind. Design criteria, determining what criteria you're going to use as a basis for the design of the project. Zoning for air conditioning systems is very important. And then we go into heat loads, heating and cooling, and from there we can develop preliminary equipment schedules. Ventilation systems, what systems are required? We probably need outside air, we probably need toilet exhaust, and there may be lots of other ventilation systems that are required depending on the project, such as switch rooms, substations, and all sorts of things, storerooms. Air distribution, setting out where the air outlets are going to be and joining all the dots with your air conditioning or ventilation systems. in developing some preliminary layouts. I'll put engineering there because that's an engineering function to get those preliminary layouts done, either in Bluebeam or Revit. And then sizing the ductwork, doing the fan static calculations, and then you can finalise the HVAC equipment selections and schedules. In other words, the air conditioning and ventilation fan schedules. So the next step is to talk about workshop drawings. So I've done all these things, and then we go into workshop drawings. So when all the equipment schedules and the preliminary layouts are completed, the workshop drawings can be produced, commonly called shop drawings. The workshop drawings are one of the most critical parts of what the mechanical contractor actually does. And going back to design or construction programs, in my experience, and probably most other people, as soon as you get a contract to do a job, the builder will say, when can we have your drawings? Okay, so right straight away, he's on to you about producing drawings. Now, this puts in pressure onto engineering to have all the data ready so that the workshop drawings can start. So it's nice if the engineers have a bit of time prior to the construction work starting so that they can do their work and pass it on to drafting. Doesn't always happen. So it can be a bit of a mad scramble at the start of a project to get all this stuff going. And you're probably experiencing that already. Shop drawings are normally produced using the Revit preliminary design drawings that the engineers have done in LOD 100 or 200. And I sent you something on LODs, but you know the sort of detail we provide. It's enough for the drafter to start the workshop drawings. And the workshop drawings will be developed to at least LOD 300 and possibly higher, even up to 500. But that's not common, but it can be done. If you're going up to LOD 500, the drawings basically have enough information on them that any information can be obtained about an air conditioning unit or a fan or anything by just clicking on that item, and the whole database of information is available. But generally, LOD 300, 350 is what the workshop drawings are produced for construction. The shop drawings will show all of the HVAC components, ductwork, pipework, equipment, etc., outlets, controls devices, in sufficient detail to enable at least the following work to be carried out. So coordination of mechanical services with architectural, structural and other building services. And a lot of that coordination is happening while the drawings are being produced. We don't produce a drawing and then say, here's my drawing, and then you start coordinating. That coordination process is happening all the way through, and quite often online, because it's easy enough to do it these days with electronic communications. Sometimes you have design hubs where a design team actually sit together in the same room or the same area and work together on developing the designs for different services, and coordination is a lot easier that way. The shop drawings enable manufacture of ductwork. Now, this for the mechanical contractor is probably his most important thing to get happening, because the builder is saying, we want to get started on site, we need to get your ductwork into these areas. The construction program will set out when the ductwork needs to be installed, which is basically called a rough-in. You rough in the ductwork, the pipework, all the equipment that can't be seen above the ceilings. And then the next phase will be to fit off. fit off the air outlets and so on, which can be quite a bit later on. There may be some prefabricated pipework. This is probably not something that you'll come across at the moment, but in a large project where you have heating water pipe and chilled water pipe, some of that pipework could be prefabricated in a workshop before it comes to site, just to save time on site. So that's interesting if you get into that. And then there's the site installation of all the pipework, ductwork, and equipment. Sometimes we go through the construction process. Unforeseen clashes can occur on site, such as another trade decides to put something in before you do and jump the coordination process or ignore the coordination process. And that may mean that it's the best way to solve that problem is for us to make a change to our duct. It's not what we want to do, but we might have to. I worked on a job years ago in Sydney that we had 4 very big chillers in a plant room. And basically, the plant room was for mechanical services, but the drainage plumber decided in his wisdom that he would get his pipe in before we got anywhere near the plant room to make it easier for him. And he had it was about a 300 diameter pipe running right through the middle of the plant room. And when we arrived on site, we said, "What's this pipe doing here?" And he said, "Oh, well, I thought I'd get it in before you got here." We said, "Well, you know what you can do now? You can take it out again," because it clashed with everything that we were going to be doing in the plant room, and he had just ignored that coordination process. And so he lost. He tried something on and he lost. So it's not worth it. You've got to communicate with other people and collaborate and work together so that everyone can get their job done most efficiently and at the lowest cost. Because for that plumber who had to pull his pipe out, it would have cost him many thousands of dollars to pull that out and reinstall it in the right location. So when all the work is finished, the shop drawings are updated to as installed status, and they go into the operation and maintenance manuals for the project as a record of what's been done. So I've got some drawings here to have a look at. You see that one all right? Some of you may have seen this project. It's the Black Rock Lifesaving Club. This is a workshop drawing. It's not complete. Obviously, it's got lots of markups on it, but it was one that I found that I had the design drawing for as well. So I might just grab that. Right, so that's this one. So this is the design drawing. You can see there's not much detail. It shows a duct, it gives a size. It's got cross-hatching, which indicates that it's got some sort of insulation. It may be internal insulation, but you'd have to check the legend to see what that is. And it's giving outlet locations and air quantities, and shows the design in basic detail. If we come back to the other drawing, this one. This is the workshop drawing that's been developed from that design drawing. So you can see now, this piece of duct, for instance, it's 600 by 450. Now, do you guys know what that means? What do those dimensions refer to on a workshop drawing?
Sheet metal.
Sheet metal size. And the insulation is where?
Can't read the drawing. Should be somewhere inside in the
Correct.
eclipse problem.
Yeah. So the actual airway size, the duct size, if you like, that the air has to pass through is less than 600 by 450 in this case. It's 600 by
Because it's
450.
internally lined.
Yeah, less the internal insulation. So that's important to see the difference, because when you look at a design drawing, let's have a look at that again. So that size on the design drawing, 450 by 300, is actually the airway size, right?
Yeah.
And if that's internally insulated, you've still got to maintain the 450 by 300 airway size and add the insulation.
Yeah.
Okay.
So in this case, if we're studying something with the fan, for example, the fan static, or we're studying the duct size, if this is internally lined, we want to consider the actual path for the airflow, which is less than the written number, right? So to check if the velocity and pressure drop as per standards.
Yes. So if 450 by 300, as shown on the design drawing, is the correct size for the airflow, then we have to maintain that. But the sheet metal will be bigger because of the internal insulation. So is that clear to you, Jella?
Yeah, I think I understand that.
So it's really important, because that can be a trap for new players to understand the difference between the two. So it's not that difficult, but you just need to, don't forget that that's what it is. You know, it's the workshop drawing will show the actual metal size, because that's what's going to be manufactured. So I'll go back to that one. So the 600 by 450 duct in this case. So what does that tell you about the insulation thickness?
75.
Correct. Yeah. So you're adding 150 to each dimension.
Yeah. So if I'm using this workshop drawing for my calculations, I'd subtract 75 from both, or 150 from both dimensions, width and height. But if I'm using that consultant drawing, I will use the size specified on the plan. I'm not going to consider anything about the insulation.
That's right. Yeah. Yeah. So it's one of those things you need to be aware of and become second nature, but don't forget. You'll find out anyway if you put those sizes in. If you put in 600 by 450 in your calculations for that airflow, you'll find that it's a very low velocity and very low pressure. And then you might say, well, why is that? And then you'll realise what it is. But just to be aware of that. But the point is that 600 by 450 is what the workshop needs to know to manufacture that duct, because that is the sheet metal size, and then the insulation. So they make the duct work first, and then they apply the insulation after the duct is made. Okay.
Yeah.
Now this drawing also shows, can you see that 1400 there? I'm just highlighting it there. That is the length of that piece of duct. So you don't get those sort of dimensions on a design drawing because it's not relevant. It doesn't matter. But in a workshop drawing,
just 400. Which piece is this? Is this the transition or the
this
horizontal
piece, that 1400 there, can you see where I've highlighted that?
Can you zoom in?
Yeah, I can't show you. It's the length of that piece of duct from that joint to that joint. And the reason it's 1400 is because most ductwork these days is made by machines, and the material comes in a
Will you
roll.
please excuse me for a sec? School is calling. I'm just going to answer. I'll get back.
Okay. So, John, we've talked about this before, the length of that section. So it comes from a 1500 wide, it's called a coil. It's a coil of sheet metal, and it rolls off the coil through the machine and gets folded up and so on, and gets folded up to form the flanges at the ends, and it finishes up being 1400 long overall. Then there's a transition there, there's a length on that, which I think is 760. It's a bit hard to read, but that tells you the length of the transition. It's got ET, which is equal taper, which means it's equal taper on each side, and probably means it's flat on the top and bottom. And you can tell that, well, actually it's not, because you see the next piece is 400 by 400, which means it's 400 wide by 400 high. This duct over here was 450 high, so it has tapered by 50 mil in the height as well. Sorry, Dil, you're back. We're just talking about the next piece was a transition which has got a certain length. It's ET, which means equal taper, so it's sloping the same on each side. It's also changed in height because it's gone from 450 high there to 400 there. Okay, so that's just a little bit of information about reading drawings. And that last piece there, the 400 by 400, is again 1400 long. Do you know where that number comes from, Dua? That standard length?
Yeah, the standard length manufactured per sheet metal. Well, will you please repeat what you said about the transition? ET is for equal temper or taper?
Equal taper.
Which is?
So it's coming in the same amount on both sides. It just means that it's those slopes of those sides are equal amount. Okay, you might have a slope on one side but not the other.
Yeah.
You might see FOB, which means it's flat on the bottom, or it might be FOT, flat on the top. Things like that. You get familiar with those things. I was just saying to Jalen that when ductwork is made, these straight pieces of duct, it's usually made from a 1500 wide, what's called a coil. It's a coil of sheet metal which rolls out through a machine and gets formed into a duct, and the ends are turned up to make the flanges, and it finishes up being 1400 long. It starts at 1500 and finishes up 1400. So that's something worth knowing. This drawing also has sizes for flexible duct. Basically, everything is shown on this drawing that the guys on site need to install the equipment in position. You'll see that there's a dimension. It's a bit hard to see, but there's a dimension here, which is from this grid line, which will be marked on the site, to the side of that unit. So they can position it one way, the other way, get it right in the right position, and then install the ductwork from there, so it all fits in. I mean, this is a pretty simple drawing. A lot of drawings are very complicated with a lot of equipment, and it's really important that it's all in the right place. So what else can I say about that? It shows the outlets. The outlets are detailed. Like in an LOD, say 400 drawing, you could click on that sorry, take that away. This description there of that outlet, you could click on that and you get a wealth of information about that outlet. Okay, who makes it, how big it is, dimensions, drawings, all that sort of stuff. So that it just depends on how much we're being paid to produce that level of detail. And normally this drawing would probably be an LOD 300, I suppose. It's enough information to make the duct, to purchase all the equipment and go ahead and do the installation. Over here, there's what have we got here? There's a fan, a ventilation system, small one here. So this is extracting air from this outlet here through a flex. Now, that last piece has been crossed off. Actually, Jalen, I think I talked to you about this job, didn't I? In Melbourne.
Yeah, that's right.
We said we didn't really need that last piece of duct because you can have 6 meters of flex. So we said we can put that onto that duct and take that piece out. And to give you a rough idea, obviously it depends on the size, but a small piece of duct like that, 250 by 250, 1400 long, probably costs about $300. Okay. I mean, this is I'm probably going back 5 years when I last looked at how much it cost to make a piece of duct.
Oh, wow.
So now it might be $600 by now because things have gone up so much. So just be aware of that, because when we talk about value engineering, it's these little things that can make a difference. Now, on a big project, if you can delete, say, 100 pieces of that last piece of duct, if you don't need it, you can delete it. You save 100 times, let's say $500. How much is that? $50,000? It's a lot of money. So
yeah.
On small jobs, you know, you can say, oh, it doesn't really matter. It's not going to save much, but it saves a little bit. But the bigger jobs where you've got scale is where you can save an awful lot of money. So just be aware of that. Once again, those duct sections are 1400 long. Here's a transition here coming into, there's an attenuator here before the fan. This transition says it's 450 long, but it says BL. Anyone know what that means?
No.
Bottom level.
Mm.
Which means it's, and that's a straight transition. In the plan, it's a straight transition. So it means it's actually sloping on top. So it's coming down on the top. Bottom is flat.
It's flat. Yeah.
Top is sloping. Okay. This attenuator is 1,000 millimeters long. It's 250 diameter. That would be a proprietary attenuator from the fan company. I didn't mention, but I'm aware that I'm sure you're aware that if you look at a dimension on a duct, so there's 600 by 450. What does that mean in terms of what you're looking at? Well, it's 600 wide. So as you're in plan, it's 600 wide and it's 450 high.
In depth of the plan.
Okay. Now on the air conditioning unit, it shows some pipe work coming in there. And it shows an access panel there. Don't forget that every air conditioning unit needs a condensate drain. That's very important, and it's got a drain somewhere. So you need a tundish. The tundish is normally provided by the hydraulics contractor or plumbing contractor, not by the mechanical. So it's preferable if you can get the plumber to put the tundish as close to the air conditioning unit as possible. Then we don't have to worry about the fall in the drain. Does that make sense? But it's common to try and get the air conditioning units up as high as you can above the ceiling to enable the condensate to drain out. It's got to slope downwards, otherwise it won't flow. It flows by gravity. You can get pumps in some of these units if you need to, but pumps can fail. So it's better off not to have pumps if you can avoid that. All right. Any questions? The half hour is nearly up. We can continue if you want to, but I know that you've got other pressing things.
Yeah.
So is there any questions on workshop drawings?
Is there any kind of slope that we need to consider when we study the condensate network?
Yep.
Or is it just any slope? Is there any percentage? Like if I'm studying, let's say I'm studying the condensate for this network, and I know the tundish is somewhere at the corner in a wet area. Is there, and I'm drawing the pipes, is there any kind of slope that I need to consider, or is it just a tilt, a mini tilt of the pipe that can work? Because all you need is just to slope the pipe. But in hydraulics, there are percentages that you need to take care of.
Yes.
Does this apply to condensate?
It's not a regulation. I don't think it's a regulation, but we try to achieve at least 1 to 100. But you'll find that that doesn't always happen.
It doesn't.
Because some of these ceiling spaces are so tight that you're lucky to get any fall at all. But if you can get some fall, then the water will flow.
Yeah,
Um,
probably
and the
0.5
wa-
to 100 will work.
Yeah. And the water, the air conditioning unit is going to be at a higher level than the pipe. So there's going to be a bit of a start there to get it going. So the pipe,
Oops, you're out of the ceiling.
sorry,
Oops, you're out of the ceiling. You're into the room.
yeah, the condensate will flow. You don't want it backing up. You don't want the pipe full of water all the time because it's going to end up being a problem. So you've got to try and get some sort of fall. And that's one of the reasons I say if you can get the plumber to put a tundish very close to the air conditioning unit, then it's not our concern anymore. We get the pipe to the tundish and we're okay. But if we have to run the tundish a long way, then we've got to be very careful. Well, the guys on site have to do it. I mean, it's not an engineering design thing. It's a site function. But there may be times when someone on site calls you, like a commissioning guy calls you or a service and says, oh, this drain's leaking. What's the problem?
Mm-hmm.
The problem probably is there's not enough slope or it's blocked up with something. That's usually the two problems. So
yeah,
probably more likely to be blocked up, but if there's not enough slope, eventually it's going to leak. It's going to overflow and leak on the ceilings, and then it's a big mess to clean up and maybe even replace ceiling parts of the ceiling. So that's important to get that right.
Okay.
Anything else?
yeah. Thank you.
Does it say shop drawing at the bottom?
On the title block.
Yeah, or do we just assume when there's this level of detail, it's a shop drawing?
Well, you'll know it's a shop drawing by virtue of who has produced the drawing.
Okay.
Okay, in this case, it's a contractor who's actually going to do the work on site. So the contractor will produce a workshop drawing. A consultant will produce a design drawing, basically, without this sort of detail. So when you're dealing with your direct clients, they're all pretty much mechanical contractors, and they will be producing workshop drawings.
Okay.
The drawings that come to you as inputs, if you like, inputs to your work, come from consultants, and they're design drawings.
Right.
And they're usually drawn at a scale of 1 to 100, although on the computer these days, it doesn't really matter what scale it is, but back in the old days of hard copy drawings, design drawings were 1 to 100 and workshop drawings were at least 1 to 50. So they're much bigger because they've got a lot more detail, and then they might break out details like this one here, for instance. They're drawn at 1 to 50, but sometimes details like that might be drawn at 1 to 20 if there's a lot of information there that needs to be shown. So, yep. Mostly you'll be dealing with workshop drawings. But, you're going from one to the other. So I wanted to point out to be aware of the changes from the design drawing to a workshop drawing in the actual duct size on the drawing. Even though it's the same airway size, it's a different dimension because of the insulation. We can talk about workshop drawings all day, but I know you've got a lot to do. If you come across something, just call me if you want to chat about it, and please do. That's what I'm here for. So you got a lot of work to do now before you finish up on Thursday?
Yeah. Got quite a bit.
Yeah, okay. All right, well, good luck. If I don't speak to you again, have a nice Christmas and a nice break. And we'll see you in the new year.
Are you available in 10 minutes if I call you, Peter, and to discuss some markups on the project?
Yeah, sure.